Hi, it's Bentley's mom. All right, we're doing chapter 11, lesson 4, and we're going to find the mean absolute deviation. So I'm on example 1 on page 838. It says the table shows the maximum speeds of 8 roller coasters. Find the mean absolute deviation of the set of data, and then describe what the mean absolute deviation represents. Okay, so what we're going to do is, here are the maximum speeds. The first thing I'm going to do, I'm just going to list the data in order that they give you. It's 40, 48, 58, 60, 66, 72, 80, and 88. Okay, so the first thing we're going to do is find the mean of these numbers. So how you do that is you add these all up, okay, and then you divide by how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, okay? So when we do that, we add them up and divide by 8, which we did a few days ago. You end up, so the mean for this is 64. Okay, now once you get the mean, what you do with every piece in the data set, you see how much it varies, or the distance from the mean. So basically what we're going to do is we're going to subtract these from the mean, every single one. Okay, so the first one, we're going to do 64 minus 40, okay? And then we're going to do 64 minus 48. Then we're going to do 64 minus 58. Then we're going to do 64 minus 60. And then when we get here, what you're going to do, because this is going to be absolute value, so we're just finding the distance from all of these numbers from the mean. The mean's right here. So we're saying how far apart is this one, and 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 this one from the mean, but we don't care about if it's going left or right. So you're just going to subtract. So when I get here, if you don't want to deal with negative numbers, you can just switch it around. So then I'm going to do 66 minus 64. So as long as you're just subtracting them, it doesn't matter which way. It's all going to be positive at the end because we're doing absolute value of all these. So then we have 72 minus 64, 80 minus 64, and 88 minus 64. Okay, and then we're going to find all of the differences here. So you have 24, 16, 6, 4, 2, 8, 16, and then 24. Okay, so once we have all of these, okay, which is after you subtract, so you have to find the mean and subtract each piece of data. It's going to take a while to do this. Then we're going to find the average or the mean of all these deviations. So we're going to add all these together. So 24 plus 16 plus 6 plus 4 plus 2 plus 8 plus 16 plus 24, and we get 100. Okay, and then to find the mean of this, we're going to divide it by how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8. And 100 divided by 8 is 12.5. Okay, and what that is that's the average, okay, of how much all of the numbers deviate from 64, how far away from it. Like this one's really close, this one's really close, and then this one's really far, it's 24 spaces away. But if we average all of it together, the average space away from the mean is 12.5. Okay, and that's what it's called the mean absolute deviation. Okay, let's do another one. So turn to example 2 on the back. Okay, and we have, it says the top 5 salaries and the bottom 5 salaries for the 2010 New York Yankees are shown in the table below. Salaries are in millions of dollars and are rounded to the nearest hundred. So you basically have to do, this is like 2 problems in one. I'll just do the top 5 salaries. So here are the top 5 salaries. And then you'd have to do the exact same thing for the bottom 5 salaries. So we have 33. Actually, I'm going to put these in order. 16.5. And then we have 20.63. And then we have 22.60. And, yeah, 24.29. Sorry, it's hard for me to see the paper, the numbers. And it's not a very good copy. 33.0. Okay. So here are the top 5 salaries. So the first thing we have to do is find the mean. So we're going to add all these up. Okay, and we're going to divide by how many there are, which are 5. 1, 2, 3, 4, 5. So we're going to do 16.5 plus 20.63 plus 22.6 plus 24.29 plus 33. And again, I would use a calculator for this. You need to know how to add these by hand, but I would spend your time like worrying about how to do this lesson, which is the mean deviation, rather than adding, but make sure you know how to do that by hand. So I get 117.02, and I'm going to divide that by 5. And that's going to give me the mean, which is 23.404. So this is the mean. So now what I have to do is subtract all of these from the mean. So we're going to do 23.404 minus 16.5. 23.404 minus 20.63, 23.404 minus 22.60, and then I'm just going to switch it around, 24.29, and if you didn't, that's okay. You'll get a negative number, but just take the absolute value of that, which will make it positive. And then 33 minus 23.404. Okay, so yes, this takes forever. So now we're going to do 23.404 minus 16.5. We get 6.904. 23.404 minus 20.63. And I get 2.774. 23.404 minus 22.6. I get 0.804. And then 24.29 minus 23.404. I get 0.886. And then I get 33 minus 23.404. And I get let's see here, 9.596. Okay, then I'm going to take all of these, I'm going to add those up, and then divide by 5. So I'm going to find the mean of all these deviations. So we have plus 0.886 plus 0.804 plus 2.774 plus 6.904 is, so when I add these up, I get 20.964, and there's 5 of them, so I'm going to divide this by 5, and I get 4.1928. Okay, and that, can you see this, Bentley, on the camera? Okay, and they rounded to the nearest hundredth, so when you round, you look at the number next to it. If it's below a 5, I'm just going to leave it at 4.19. And then when you round, I call it the squiggly equals. That just means approximate. Okay? And that is it. Thanks.